Assalamualaikum warahmatullahi wabarakatuh and a very good day. Welcome back to my channel Dr. Zul Hilmi, especially to all my students from University Technology Malaysia, Skudai. So today we will discuss a new topics which is rigid body couples. Okay, actually this is not really new because it is a combination of the thing that we have learned from previous topic, which is moment. Okay, moment in two dimension and also resultant two dimensions. So we will cover, we will combine these two, moment 2D and also resultant 2D in this new topic which is couple. So normally you will have no problem to understand this chapter. Okay, so from previous chapter we have the moment 2D. Okay, so from previous chapter we have moment 2D. Let's say we have one component like this one. Okay, one simple component, and then we have force F equal to 10 Newton. Okay, F equal to 10 Newton. So let's say we take one point A 1 meter, point B and point C. Okay, all the distance is 1 meter, 1 meter. Okay, so if I'm taking the moment about point A, for example, so MA equal to 10, which is F times D, the force times the distance perpendicular to it. Okay, the shortest distance from the line of action of force F towards the point. So equal to 10 times 1. So we have 10 Newton meter and the direction is clockwise. If I'm taking a moment about point B, it will be F times D equal to 10 times 2 equal to 20 Newton meter, still clockwise. And moment about point C is also FD, 10 times 3, 30 Newton meter is clockwise. Okay, so that is for moment. This is the thing that we have already learned from previous chapter, the moment. Okay, so now let's say what happens if we have one more force which is same as this one but opposite direction. Okay, same magnitude, which is 10 Newton, same line of action of force, okay, but opposite direction. Okay, so we have two same force in terms of magnitude and line of action of force. The only thing different is the direction, which is opposite direction. Okay, so if we have these two forces, okay, these two forces, if you want to calculate the moment about point A, okay, this is the point, so our force equal to, so let's call it this one F1, this is F2, okay, which is the same magnitude, equal to F1 times D1 plus F2 times D2. Okay, so in this case we have to here 10 times 1 plus turn this direction clockwise, turn this direction also clockwise. So both direction is clockwise, so positive, plus 10 times distance is 2. 10 times 2, so this one will be 10 plus 20, which is 30 Newton meter, and the direction is clockwise. Okay, if I'm taking a moment about point B, equal to 10 times, so F1 to point B, which is, this one is 2 meter, plus this is clockwise, this one is also clockwise, so 10 times 1 is also Newton meter clockwise. And if I'm taking the moment about point C, it will be here 10 times 3 plus 0, because it is on point C, so it is equal to 30 Newton meter clockwise. Okay, so notice that if we have two same forces, same magnitude, same line of action of force, but only the difference is opposite direction, at any point you take the moment, okay, the magnitude or the moment calculated will be same at any point on that rigid body. These two forces, same magnitude, opposite direction, they create same moment at the whole component. Okay, at any point at the component, we call it as couple. Okay, we call it as a couple. Okay, so and the couple itself can be represented by so the couple can be represented if it is as this one or this one, same as in moment. Okay, moment created by this couple. So clockwise or anti-clockwise, or we can also using this. Normally we use this one, or the other one is so either this one or that one. So both same magnitude, opposite directions, we create the moment clockwise. This one will also create the moment counterclockwise. So we can represent this couple, moment created by this couple, as a moment here, clockwise or anti-clockwise, or in this form. So in the question later on, you will see that some will give this one, then some other will give this one. So, but it is the same thing, but you can represent it as one of this. Okay, so in this case, we know that at any point on the rigid body, the moment created by this couple will be same. So if you have this one rigid body, and then you have two forces, if the system said to you replace these two moments by couple, force couple system, you can put at any point equal to 30 Newton meter, or if you want to put here, or if you want to put here, it will be same. It depends on the question where you put, but you know that at any point you put that moment, the value will be the same. Okay, there is for couple. Okay, actually for this particular chapter, the question that will be asked you is transfer the forces and the couples given into a force couple system at any specific point. Okay, let's say we have where's the question? Okay. So let's say we have this question. Okay, let's say we have one simple component like this one here. This is 2 meter, this one is 3 meter, point B, point A, point C. Okay, 2 meter, or we put it right in the middle here is 1 meter, 1 meter. Okay, and then we have one force here. Let's say we call it this one. F1 equal to 10 Newton. This is 30 degree. And then we have this one. F2 equal to 20 Newton. And one more here. F3 equal to 20 or 30 Newton. Okay, and then you are given one moment created by a couple. Let's say here we have one. What is it? Let's say we have one here. Okay, so there is let's say we have 10, 15 Newton meter. Okay, and the last one we have one here. 5 Newton meter. Okay, so notice we have everything. Okay, so we have 1, 2, 3 forces. Okay, F1, F2, and F3, and we have moment created by couple, which is this one. This one first 15 Newton meter, the other one is 5 Newton meter. Okay, now the question in this case, we said that replace all forces and couple. Okay, where is it? Force couple system. Replace the system of force in the figure in the system. Okay, replace all forces and couple into a force couple system at point A, for example. Okay, so the question asks you to replace all these forces and couple into only one point. Okay, so our end result is we will eliminate all the forces, all the moment at various point here, but we will put only at one point, which is point A. Okay, so what the question really asks is, if you want to eliminate this one and put at one point, but it will give you same result. Okay, the component will feel the same thing at point A. So what is the value of force and couple at point A if we replace all this force and couple system? Okay, so the thing what we do is, normally the simple step that I will follow. The first one, I will create the sigma moment at point A. So the first step. Second step is sigma Rx. Third one, sigma, sigma F, so Rx, Ry. And then the fourth one is R, and then the fifth one is theta. And then figure the answer. Okay, so you follow this step, sigma moment, Rx, Ry, R, and theta. Okay, so in this case, there's nothing new. Sigma moment you have already learned from maybe chapter 6, if I'm not mistaken. We have chapter 6 for the moment. Okay, and Rx, Ry is from chapter 2, the resultant force. Okay, so you know exactly what to do, only now to rearrange everything and put in point A. Okay, so we start by one sigma moment. Moment at point A equal to, first thing to do is to add the moment created by couple, which is these two. Okay, so you choose, because we will have several part, okay, several moment, opposite direction and so on, so we have to choose one direction as our guideline. Which direction we consider as positive direction? In this case, I consider clockwise as positive. So sigma moment at point A equal to, I'll take the first one, this one. If you look at this one, so okay, one force pulling this direction, the other one pulling this direction, so the direction will be this one, counterclockwise, so negative 15. Okay, this one is negative 15. This one is clockwise, so plus 5. So this is the couples given, the moment given, created by couple. So this one is directly given to you, you just add here. The other one is moment created by these forces, 1, 2, 3, 1, 2, 3. Okay, the first one, F2, go to 1, you put a pin here, pull this direction, so it will turn that direction counterclockwise, so this one will be negative. Okay, so negative 20 times the distance is this one line, the other line here, so we have 1 meter. This one you can resolve into x and y. This is sine, this is cos, so eliminate this one, cos, sine. The one that is cos go directly to this point, so this one will be 0. You only have this one, and we put pin at A, pull this direction, or consider this one, so it will be positive, clockwise, plus 10 sine sine 30. And the distance is this one, 2 plus 2, 1 plus 1, so equal to 2. And the last one here, you put a pin here, pull this direction, is return counterclockwise, so negative 30. The distance is from here, one line, this is second line, so this is the distance is, oh no, where is the, oh I didn't give the distance, so let's consider this is 3 meters, so we have 3 meters here, so 3. So we solve this one, negative 15 plus 5 equal to minus 20 equal to plus 10. We have sine 30 times 2 equal to, and then minus again 30 times 3. So we have minus 110. So equal to minus 110 Newton meter, meaning that it is 110 Newton meter counterclockwise. Okay, so we have the first one, sigma moment at A, so I will write it here. Sigma moment A equal to 110 Newton meter counterclockwise. Okay, so finish our first step, sigma moment. Okay, so we go to the second one. Erase this one. Okay, the first one is to calculate the moment created by this couple and created by the forces. The second part is to calculate the sigma F, which is the Rx. One direction is positive, Rx equal to. Okay, so this is in one direction, this is negative, so we have minus 10 cos 30. This one is positive, plus 30, so equal to this one. Cos 30 equal to time 10 equal to, so 30 minus answer equal to 21.3, 21.34 Newton, so which is this direction. Upward positive sigma fx equal to rx, so this one is complete. Ry, okay, ry, so we have this one minus 20, this one is in x, so 0, so this one plus 10 sine 30, so you have 10 sine 30 equal to minus 20 equal to minus 15, so actually 15 Newton downward. Okay, so we have Rx, Ry, so you calculate the R. From here you have R equal to square root of 21.34 squared plus 15 squared, and the direction is Rx is to this direction, this is Rx, and then Ry is downward here, so it is from start to end here, so here is your R. Okay, so Rx plus Ry, so this is start point, this is end point, this is your R, and this is your theta. So R, calculate this one, 21.34 squared plus 15 squared, okay, square root of these two, 26.08 Newton. So we have Rx, Ry, R here, theta equal to tangent minus 1, y divided by x, so y is 15 divided by x 21.34, so you have theta equal to 21.34, so we have tangent minus 1, answer equal to 35 degree. Rx, Ry and theta. Okay, so you have already calculated the moment Rx, Ry and theta, but in this case, because the question asks you to replace everything into a force couple system at point A. So you have to answer the question. Okay. At least if in this case you have a simple component, just redraw the simple component. If the component is complicated, you just draw the point A. Example here, because the question asks you point A. Okay. And this is the point A. Okay. So you have to replace this one into a point A. So you have force, which is this one, 26.08 Newton. This is 35 degree. Okay. And then we have a 110 Newton. Okay, 110 Newton meter. Okay, so this is your final answer. This should be your final answer. This is the thing that is given to you, several forces, several couple. You replace everything into only one force and one moment at point given. Okay, in this case at point A, so this should be your final answer. You have to redraw back your component, or if the component is complicated, just draw the piece of the component that involve the point that you need, point A, and then draw the force with its direction and the moment with its direction. This is your final answer. Okay, so that's the only the thing for this chapter. So the thing is, you need to calculate moment, Rx, Ry, R, and then theta, and replace in the point that is asked to you. Only that one. Okay, so later on we'll go to one or two more example question from our books, and then we finish for this chapter. Okay, see you later.